Hello friends, today we'll start with the third session of the computer numerical control sessions. So today what all we are going to discuss here is basic of part programming, presentation and miscellaneous functions, cutter compensation in billing operations. These three topics will be discussed today in this video. So let us go for discussing one by one. Let us take the first, that is basics of part programming. What all we need to understand in part programming. Okay, so here you can see what is a part programming. First, it is a set of instructions which instructs the machine tool about the processing steps to be performed for the manufacture of the component. Okay, it is a set of instructions given for the machine to do the specified work on a job piece. Okay, so that instructions how to do, what dimensions has to be maintained, what operations has to be done, everything, all the details will be given through a part program. Fine, so that is what we call it as a part program. So how we write it? The first line of the part program, here we have that one here. What all the things which indicates here? First, if I take n10, that is nothing but the sequence of the line, sequential of the sequence of the program writing, first, second, like this we give the sequence for that one, that is n10, that is what the sequence we have. Next comes g90, z01. So these are preparatory functions. Okay, that is commonly we call it as positioning functions, which defines the positions of the spindle or the work part on which where the work is going on. The positions are being defined by these G codes. Okay, next comes the X and Y. X and Y, you can see here, that is nothing but the dimensions what we give. Next comes F, that is feed rate. Here F100 means 100 feed rate we have been given here. Next, spindle function, that is speed of the spindle, how at what rpm it has to be rotating, that is S1200 what it is being given. Next comes the tool function, which is which tool has to be selected, so that is TT01, 02, 03. The different tools depend upon the operation needed, what type of tool has to be selected. Last comes M03, that is nothing but miscellaneous functions, that is program start, program end, such functions what we call it as miscellaneous functions. So like this what we write the programs, what all the things has will be there in the sentences of the lines of the program. So next comes the programming format, what all the formats will be there. We will be going on discussing these lot of things one by one we will discuss here. So first one is program number. Okay, first comes the program number, that is 0102 or whatever the number you want to keep, you keep the number for that one. First the thing what we need to take care. Next comes the sequence number, block identification number. Some sequence number will be always given for each operation or anything, so those things we have to be taken care. Next comes the preparatory functions, G codes. Okay, that is Z00 to Z99. It so many commands are there which specifies different things here. So this prepares the machine for next operation, that is what operation has to be done, what position, where all the positions has to be defined, that is defined by the G codes. Next comes XYZ, primary motion dimensions in the XYZ directions respectively. Okay, these are primary motions. UVW, that is secondary motion dimensions in XYZ direction itself. Okay, next comes PQR, tertiary motion dimensions, like that. Similarly, IJK, okay, distance to the center or threadlets parallel to the XYZ respectively, parallel to XYZ, that's it, that is the important thing. Then comes ABC, that is angular dimensions around the XYZ dimensions XYZ. I mean along the x-axis any angular dimension we need to give, A will be A something, the number value will be given. Similarly YZ it will be given. Next R are the parameters what we want to for example radius, like this parameters what we want to give. F is nothing but feed rate. S is spindle speed, that is cutting speed. T is the tool number. Next M is a miscellaneous function, and EOB, that is end of the block. So these are some of the commands what we use there. Next program key letters, what are the letters we use, key letters. O, okay, that is the program number first. So N sequence number, J preparatory functions, X axis designation, Y axis designation, Z axis designation. Dimensions will be given in X, Y, Z. R is radius designation, whatever the radius we want to give, R30, R40, like this we give. Next feed rate designation, that is F F100, F20, that is feed rate what we give. Spindle speed designation, S. H is a tool length offset designation. D is tool radius offset designation. Few of the key letters what we use for what defining. Okay. Next, important G codes. Okay, let us have these things. The main things what we need to write a program. Okay, Z00 rapid traverse, that is nothing but from moving point to point motion, that is rapid traverse. Okay, one point to another point, only point to point motion we are going for using Z00. Okay, where from one point to another point it want to move. We are not bothering about the in path, in the way how it moves, how the spindle moves. Only the end position and the start position are important for us. There, that time we go for using Z0. Example is drilling. Okay, from one point to another point it has to move. So that is what G00. Next comes G01, linear interpolation, the line through which it travels. Okay, that is defining what we are giving is Z01, linear interpolation. Okay, milling operation and all will be given will be commanded with Z01. Next, Z02, circular interpolation clockwise, that is for the radius of radius curvature and all, chamfering and all what we do. Okay, so those things we need to go for with G02, circular interpolation clockwise. Okay, in clockwise direction. Z03, similar circular interpolation in counterclockwise direction. Okay, so G04 dwell, G08 acceleration, G09 deceleration. Like this we have G17, 18, 19 X, Y, Z plane, G20 unit inches. Okay, which unit we want to consider, inch units. Okay, G20 like this, G21 metric units. So G40 cutter compensation cancel, G41 cutter compensation left, G42 cutter compensation right. Further we are going to study these things in detail. So G80 fixed cycle cancel. So G81 to G89 fixed cycles are there. G90 absolute dimensions, G91 incremental dimensions. This is also very important what we need to define. So these are some of the G codes what we have. Important M codes, that is machine tool miscellaneous functions. M00 program stop, M01 optional program stop, M03 program end, M02. Okay, M03 spindle on clockwise direction, M04 spindle on counterclockwise direction, M05 spindle stop, M06 tool change. So M08 coolant on, coolant off. Okay, clamps on, clamps off. Then program stop. Okay, that is M30. Mainly we use these M codes. A lot of other things are there, but we are going to use these things. Now let us come for how to write the programming and different programming part. So part programming. Manual part programming, commonly it is nothing but manually is nothing but directly we are writing the program, and according to that using the keyboard we are entering it directly to the machine by the operator itself. Okay, the operator writes a set of codes to define the program, and the program is fed to the CNC system through the controller. We are using the controller system, and we are feeding the program to the machine, and according to that the machine works. That is what we call it as manual part programming. If we go for computer assisted part program, that is computerized part programming, the geometric and constructional data regarding a part is fed to the computer. I mean that design what we make the component and all, it will be there in the computer. Okay, and according to that what all the operations has to be done, we will define the operations there in the software. We have a lot of softwares, in that we will define the operations what all has to be done. We check whether the operations correct or not, then we generate the part program. The software itself generates the part program for the given operations. Okay, so we have a lot of softwares here, that is Capstone, Capsmill, Mastercam, SolidWorks. Like this lot of programming softwares what we have here. Okay, it is nothing but computer assisted part or computerized part programming. Okay, next we have few of the things what we need to learn in a programming part, that is machine, program and part origin. Machine origin, program origin, part origin, these are three origin points. Okay, we need to always keep in mind. Machine origin, it is nothing but a fixed point set by the machine tool builder usually it cannot be changed. Commonly it will be not changed when the machine is been built up, constructed. At that time only basically a point will be defined as the origin for that machine, that will be always stored in the machine. That cannot be changed. Okay, any tool movement is measured from this point. Okay, the machine itself measures from that point, that origin, because the machine itself has its own origin. The controller always remembers tool distance from the machine origin. Next comes the program origin, is the point from where tool starts for its motion while executing a program and returns back at the end of the cycle. At the end of the cycle, it returns to back to the 0 0, what we define the origin in the program. Okay, that is nothing but program origin. It will the spindle will start from there and it will return back there. Okay, so now machine origin is different, program origin is different. We have one more, that is part origin. Part origin is nothing but origin of the work part. Okay, again it can be set at any point inside the machine's electronic grid system. We can change it, so we can set it, we have to set it actually according to the part where the part is being placed and all. With that thing we set it, so that thing will be fitted by the operator itself. Okay, establishing the part origin is also known as zero shift, work shift, okay, or floating zero, or datum. That is what different names what we call. Okay, so that is what we have, the part origin. Let us see how it will be there in the diagram. It will be very easy for you to understand. Lathe machine, if I take a lathe machine, what all the machine origin, how it will be there in the lathe machine. Machine origin you can observe here. So we have machine origin, then program origin and part origin. Okay, we have a lot of three things here. Machine origin, where it is a basic thing which cannot be changed. Then program origin, where the spindle is been stopped. Then part origin is at the part, you can see at the XZ. Okay, part origin is there. So that is what we have in the lathe machine. Next comes in milling machine. You can see again machine origin, it is at the top. At the mid we have the program origin, where spindle comes and will be in ready position to operate on that one. Next, part origin is at the part. You can see the circular part a thing what we have shown there. That is what we have, the part origin, the start point where the operation starts. That is nothing but part origin in a milling machine. Okay, so these how I hope all it is clear: machine origin, program origin and part origin. Next comes the commands what all we use commonly. It is very easy to understand here. G00 already we have discussed, rapid traverse. Okay, so it will be from one point to another point, XYZ. Z00 XYZ, like this the coordinates will be given. Z01 linear interpolation from one point to another point along the path what it works, that is Z01. So Z02 circular interpolation, clockwise direction. Z03 circular anti-clockwise direction. So next is the cutter compensation. Yeah, this one we need to know when we are writing a program. So Z40, Z41, Z42, these are the three commands what we use for the cutter compensation. Now what is cutter compensation? See, if we use a cutter compensation, it allows the program to use the part geometry exactly as from the print for programmed coordinates. Okay, without using cutter compensation, the programmer must always know the cutter size. I mean, it is nothing but the line what we specify from one point to another point, and the cutter size what we use, the radius of the cutter size, will be affecting the dimensions what we actually have. Okay, if we give the midpoint of the cutter will be the path from which it is traveling, but the diameter of the of the cutter size will affect the dimensions. Okay, I hope you can understand that one. If further we have the diagram, we will better understand it. Okay, so if a different size cutter is used, the part will not be machined correctly. Okay, so and for avoiding this, we will always give a cutter compensation. What all types of cutter compensation are there? You can see here. It will be very well understood now. So you can see in the green, that is with the cutter compensation, it will be out of the line through which the point, the workpiece, the edge of the workpiece has to be there. It will be out of the line. Okay, so the commands will be given with respect to center point of the cutter. You can have the circle. You can see this circle, the center point of this circle. So will be the path, the programming path. But if we give cutter compensation, it will consider that cutter compensation and move aside, okay, away from the workpiece, and actually we get the required size. You can see here red point also, which is without cutter comp. You can see it is halfway inside the workpiece, halfway outside the workpiece, where cutter compensation is not given. Now if it goes on cutting like this, means the red dot what you see, if it goes on cutting like this, means what happens? The required size we can't achieve. So this is what the difference between with cutter compensation and without cutter compensation. Okay, so that is what we have here. How the cutter compensation commands work, you can see here. So we have G40 cutter compensation cancel. We don't have any cutter compensation. Center point of the tool to center point of the tool, the tool travel will be there. Okay, G41 cutter compensation left side. I mean again we have the sides when the tool workpiece is left of the tool or workpiece is right of the tool. That thing we always keep in. We need to give the instructions to the machine. So now if the workpiece is left, I mean left to the tool or spindle, okay, so we will go for G41. There the cutter compensation will be there. It moves towards the right and it will go on cutting. So if we have G42 cutter compensation right, if we want to give the cutter compensation right side, okay, so again that is what the workpiece will be on the left side. It will, the spindle will be shift towards right. Okay, so like this we have the commands G40, G41, G42. So this is how we go for defining the cutter compensations. Okay, this is that's it. We have with the videos. So remaining thing we discuss with the different topics in the next video. Thank you.